thank you for showing up. I'm really happy that we are a good number here. And I will tell you for a fact that we are going to learn a lot, right? We're going to learn a lot. So yeah, this class will be very um interactive, right? So on the settings, I'm actually allowing everyone to be able to speak, right? So if you want to speak, you can just unmute and we'll learn more. So yes, so I mentioned that we actually have a paid membership, and what that is for is basically we have some extra classes. We send the recordings for these free classes we have, and we'll be giving out five five free courses or free membership access to five people here. So yeah, it's really those that speak honestly, right? But I said that actually I've been able to allow everyone to speak. So if you want to speak, when there is a question, please just unmute and we'll listen to you. All right, all right. Um, so let's just go straight to what we'll be learning today. So as you said, we'll actually be looking at massing, and honestly, it's actually a very important course and something I had to learn outside outside architecture class, right? Because it's not something that was taught. So it's one of the things that most of us miss. The thing is that most of us actually mass, right? And I will explain why I said that. Like almost everyone that is in architecture school actually understand massing, but we don't know massing for what massing actually is, right? So now, let's. Why are we doing this? So now, what really triggered um us even deciding to have classes like this is really built from the fact that we that started it were able to learn some few things that we believe if we can share would actually raise the standard at which we put out work, especially in architecture, right? So it's something that we is really on our necks in the sense that we really want to see, really want to see this work, right? So please just open your mind. You're going to learn a lot, right? You're going to learn a lot. I wouldn't be the only one speaking throughout this course, right? But I can tell you for a fact that you'll be able to learn. So now I want someone to hmm, based on their own understanding, there is no wrong answer, right? I really want someone to at least tell us what they understand by massing. Massing, yeah. Please, if you want to talk, can just unmute yourself. Can just unmute yourself. You can just unmute yourself.
Good afternoon. Good evening.
Please, I'm waiting. If you have any question, you want to tell me anything, please send a message to the contact I'm going to send to our channel now. I'm still waiting for someone. Yeah. I'm waiting for someone. Hmm.
Hi, good evening.
Chioma Udoka, can you hear me?
Hi, good evening.
Chioma Udoka, can you hear me? Please, if you can, unmute yourself and respond.
Yes, I can hear you. Good evening. Can you hear
Sorry,
me?
I honestly did not hear you.
Can you hear me? Good evening. Oh,
All right, all right.
Good evening.
can you hear
Um,
me?
Yeah, Chioma, please, we can hear you.
Okay, good
Good evening.
evening.
Okay. I can hear you. Yeah, good evening.
I think massing is like over a 3D, three-dimensional form.
Okay, David, you said massing is a three-dimensional form, right?
Yeah, like a complex shape, something like that.
Hmm, hmm, hmm. All right, all right, all right. I think that's actually a good answer. Chima, you're actually speaking.
Okay, yes. In my own understanding, I think massing is just the form of a building.
Hmm, okay, okay. I think that's more spot on. That's more spot on. So please, can some of you send me a message? Uh, that's to yeah. Please send me a message so I can add it to our membership group for answering the questions. All right. So now, let me now explain exactly what massing is. Now, David said that massing is actually a three-dimensional shape of a building, uh, which is actually correct, but honestly, it's not the entire thing, right? So now, massing, let's call it a perception. So it is really not um, necessarily three-dimensional, but it's just a perception of a shape, form, or a size of a building. Honestly, uh, a massing is not tied to 3D objects, but 3D objects are the best way of viewing a mass, right? But massing is not tied to 3D objects. Now, one thing that you should be able to know is that massing, honestly, is the basis of every design. Now, one I mentioned that every one of us actually do massing as long as you're in architecture. I actually know what I was saying because your massing actually starts with uh so I was saying your massing starts with your sketches, right? So also look at your sketches also as massing. I would show you in the course of this class, I will show you a replica of the original sketches for the falling water because you will be able to see the way those sketches were able to be used to depict something or to explain the concept. So even from massing does is not only about conceptual, right? But as we go into the course, you see more use of how massing can be used. So from there, what can we use massing for? Number one is conceptual design, and and form exploration. And this is the one that most of us know, in the sense that when it comes to okay, you want to do your concept, you have at least those that do box building, you have a box, then you cut this part of the box, then this, then this, then this, then this. When it comes to most times the form of the building based on the geometry, is your building a square, is your building a rectangle, is your building trapezoid? Yes. So like when it comes to the form and the shape of your building, massing has a very large part to play, right? Massing actually has a very large part to play. When it comes to conceptual design, when we okay, one of the things that you can also see is that, oh, why do we cut one part of the building? Oh, because we want ventilation to enter that side. Why is there a void in the middle of my building? Oh, because it's a courtyard. Do you get? So all the geometrical analysis, or trying to understand how your building is as a three-dimensional object, right? You're able to understand, you're able to actually create a mass, or we can actually call that a mass. Another use of mass is to know the relationship to neighboring buildings, skylines, or topography. Now, one of the uses of mass is that when it comes to your site analysis, right? So when I mean site analysis, when it comes to you trying to know what if the height of my building, right, how it is going to affect the height of this other building. So you could actually either sketch something, or you can do a physical model, or you can do a digital model. So you'll be able to know how your building is going to affect another building, or how your building is going to sit into your site. So when you're even given a site and you're able to mark out your site with you're able to mark out your site based on the setbacks, right? Based on the setback law and everything, right? Or the accepted one by the regulatory bodies, right? We're able to actually map out, right, those your setback. What you actually have is basically the mass of your building, right? So even to your topography, okay, if you are trying to understand how you're even going to do cut and fill, right? So you could have your topography on a section, and even just sketch how your building is, your three-dimensional object is even going to sit on that piece of land. So is it going to have some columns that are hanging? Is it going to cut into one side? Are we going to fill another side? So the way you would know that is actually trying to do like all your conceptual massing, as we said. So I said that you can definitely do it with sketches, or you can do it with actually doing a physical model, or you can actually do it with doing a digital model. Another thing is daylight and ventilation. Now, another one of the most useful or directly useful way of actually doing a mass, right, is actually trying to understand how your daylight and ventilation is going to be. Now, the level at which we actually use this in Nigeria is really not as much, right? To an extent, because we understand, okay, where the major trade winds are coming, where the sun rises and sets. But when it now comes to the context of, oh, how it relates with the environment, right? How does the daylight relate with the environment? If I have a very small building in a group of skyscrapers, right, or a group of high-rise building, how does that affect? So to be able to design well, and be able to design based on those information, that's where massing really helps. As I said, you can use it with physical model, you can use it by doing a digital model, or you can use it by actually doing your actual sketches. Um, Another is now ventilation. Now, the way people understood, or the way people were able to conceptually mass for ventilation before, was that they do a physical model. They do a physical model, and they are able to map out, okay, where is this building, or where is this space, this and this and that, and they actually do use physical fans, right, based on based on the direction of the prevailing wind, right. So all this is just trying to tell us that the whole use of massing is, number one, to understand your building, and to be able to design based on constraints, right? To be able to understand how those constraints affect your building. So now to circulation and spatial organization. Now, I'm currently doing my master's in architecture, and one of the projects that we are working on this semester is an high-rise office building. And so one thing I was able to learn was that for me to be able to know, number one, how high my building is going to go, I need to actually map out what each floor is for, right? Now, me now mapping out what each floor is for, I need to now actually zone them, right? So now, one thing that was able to help was actually having physical blocks, right? Not actually digital blocks on Revit, to be able to say, okay, this is this floor, this floor, this floor, this floor. Oh, this floor is not affecting this floor. Oh, my podium. Oh, when I do my podium, and when I do my solar analysis, I already know where my the like my MD's office, or the head of department's office, is going to be, or where my solar panels are going to be, or where how I'm going to position the fins, which were also modeled based on the massing, right? Another thing that massing helps again is to be able to design to respond to climate, okay, based on your overhangs, right, your recesses and orientation. So these are mostly basic things that you can do with Revit, at least for those that have started using Revit. Another is zoning and compliance, definitely. So one thing that you would be able to see is that being able to have your sketches, physical model or digital models, you can be able to achieve all these things in having a very good and compact design, right? So from there, we'll be looking at, um, as I said before, there are three main ways to be able to express massing. Number one is by physical models. Number two is by sketching. Number three is by digital models. Now, uh, let me show you some examples. Okay, so now you would see in this diagram, if you're able to see the diagram well, you'll be able to see that this is actually like blocks representing neighboring buildings, right? And you will see that the one marked in the red dots, or the red broken lines, right, is now the actual building. So what is really happening, the person is trying to explain, oh, this is how people are be able to access the building. Okay, based on the form of the building, this is what is happening. Oh, I'm extruding this side, I'm extruding this side, I'm extruding this side. And most times you see that the reason for extrusion, or the recesses, is really based on either ventilation, or more space, or we need this, or we need this. So to be able to have informed decisions on your design, right, massing is very, very necessary. Now that I said that, so this is actually like actual sketches of the falling water building that most of us know, right? So you can see that this is a 3D sketch of the building. So now you can see that this is not perfect. So depending on what you want to check, what you want to express, right? So here the person um, sketching this will probably was trying to say, oh, this is how, based on geometry, there's this block here, and under this block, there is now this rectangle or cuboid, and this, there is the cube on under. So that's how the main mass of the building is. So even look at this, to be able to see where the water actually flows, the topography. So you'll be able to see that all these things we're trying to check, the zoning, topography, climate, they can be done through those three ways of expressing a mass. Now you can see this is actually a physical model of a building. And one thing that physical models are able to help is to be able to see your building in a very good scale, right? So the different geometries you have in your building. So this again is another sketch. Another sketch. Again, I'm saying that they are actually masses. They are actually masses because you are trying to express something, right? So yeah, let's now go back to our slides. So I'm actually going to share the slides if you really need it though. All right. So next we'll be looking at majorly looking at digital models, and in architecture, right, there are really four, as I would say, four major softwares I've seen that we usually use. One is SketchUp. SketchUp is a very beginner friendly app. Most people in architecture really started with SketchUp, I guess, right? So SketchUp is a very simple app to use. You push and pull, and it's very easy, right? And that's one of the things that you will need to look out for when trying to mask something. How easy is this? How easy does the software allow you to mask? Then Revit, which we are going to be looking at today, which is like the most um, popular architectural software. Then Blender, people actually use Blender, right? But I've seen that it's really not popular, and is not a thing that everyone uses, right? But Blender is good. So now to Rhino, which is actually one of the most used software for massing in the architectural space. Probably not is not so popular in use in Nigeria, but I can tell you that, take it from me, Rhino is simpler than Revit. Yeah. So for those that actually think that Rhino is more complex, no, Rhino is really simpler than Revit. So, but now let's now look at the whole process of we even designing buildings, right? So let's say, for example, again, we are trying to do a high-rise building, and you are trying to see how the space that you have on your ground floor is affecting the space you have on the top floor. Let's say you have a tower, right? Just one tower. Now, let's say you now have a particular shape on the ground floor that is different from the shape on the top floor. When it now comes to trying to iterate, I mean, okay, let's say the one you did now, there's no space for the janitor's closet or the core of your building or the middle of your building needs more space. What do you do? So you now, if you are using a sketch, you now have to either erase and redraw it, or if you are using Barrow, you find another paper. If you are using a physical model, you don't cut the thing, and you see that the thing that you cut is wrong. So it's either you are cutting and joining, right, or you are what's the name? You are cutting and joining, or you have to cut another piece of the material using to do your physical model. But one of the good things about digital model is for it to be able to iterate, right? It does not put a limit to the amount of creativity that you can actually have, right? So it just makes things easy in that sense. All right. So that's where things like parametric massing or parametric modeling comes in place, right? Now, there are some softwares that allow for parametrics. There are some software that don't. Now, let me explain what parametric means. Now, people think that parametric is anything that's complex. No, parametric is not anything that's complex. Parametrics is just anything that has parameter. For example, the length of a cube is a parameter. The height of a cube is a parameter. So now, let's say you have a tower that is just a cuboid, in the sense that the base is a rectangle, and the number of the floors your client is asking for is increasing, right? So now, what you now need to do is that parameter called height of that my cuboid will now have to be increasing. That's what it means by something or a form is parametric, in the sense that the parameters of that form can be actively can be actively tweaked or changed or increased, reduced, right? So that's what parametric means, right? And there are two main softwares that do it well. That doesn't mean that other softwares don't, but there are two main softwares that do it well, and which is Grasshopper for Rhino and Dynamo for Revit, right? So now I'll try to explain how these softwares work, because again, people think that it is complex. It is not complex, right? Okay, there definitely is a level of complexity, but I can tell you that level of complexity is based on the complexity of your design, not the complexity of the software itself. So the softwares are not complex. Now, for Grasshopper for Rhino, which is a visual programming app, let me just explain how it works. It works with nodes, right? You might not know what nodes are. Let's call them blocks. Let's call them blocks for this explanation. So one block can be able to depict numerically. I mean, let's say you have one block that is controlling the height of the building, one block controlling the width of the building, and one block controlling the length of the building, right? So let's say I need to now increase the length of the building, but I want the the height and the breadth to stay the way it is. That's how Grasshopper actually works. So is they are trying to tell you that, okay, do this and this based on what I give you, right? And make sure that, oh, this doesn't move or this moves. Make sure that you divide this block into 4, something like that. So you're actually giving the software commands based on the nodes, right? So the same as Dynamo actually. And I can tell you that when you're able to learn this thing, there is a vast, honestly, there is a vast possibilities that you can do with your designs. All right. So I hope we are all understanding the class. What is what I've been saying. If you are understanding, please just put a reaction somewhere. Please just put the reaction somewhere. Please just put the reaction somewhere on our channel, so that at least I will know that we are all following. All right. Thank you. Okay. So now, let's now move to why we are doing Revit. Why did we choose Revit? Why is it Revit that we decided to do? Why did we not do Rhino? Right. So now, I think the first reason for me is the fact that Revit is, number one, primarily a design software for architects. So you can be able to understand anything that we even do. So it's not a new environment. So one good thing about Revit that no other massing software is able to do is that Revit has a dedicated massing environment. So you can do your conceptual mass, try to iterate on different things, and you still have your building. So one thing that I know people think is that when you do a mass, you automatically have a building. No, your mass are just geometries, except you give them a meaning, or that, oh, this side of my mass is cutting wall, or this surface is a floor. It is just a mass, right? Except you tell it that, okay, that is what it is. Massing in Revit just gives you a surface, lines, and all those. So another is the parametric design capabilities. So now I know most of us have really learned. So those that have learned massing or know, let's say, the basics of actually doing massing. Well, one of the different things that you're able to learn here is how to make them parametric. In the sense that, as I explained before, when you need more floors, it will give more floors. When you need it to increase its height, to give you more height. When you need it to increase its width, to give you more width. So we'll be able to actually do that and make sure that it can be able to help our designs, right? Another is the ability to be able to seamlessly transition from massing to building. Revit is just super good for this, right? It's the other software you can use, as we said, was Rhino, but Rhino can't give you this. So you cannot do a mass and tell Rhino that this is a floor. No, Rhino just knows it as a rectangle, or just knows it as a cuboid. It does not know it as a floor, right? So one of the good things about Revit is that I can do a very complex shape. Oh, you don't scatter, and I come back to the normal environment, and I'll tell you that, oh, this surface like this that is looking very wavy. That surface is a cutting wall, or that surface is an aluminum panel, or that surface is my roof, or that complex surface is a wall. Do you get? So that's one good thing about Revit that no other software is able to do. Another is analysis tools. So we, at least most of us that know that we could do energy analysis in Revit. How many of us have actually done it before? I'm very sure it's very few, right? Now, for you to do energy analysis, right, you need a mass. You can use a building, but to effectively do it, right, it's better to do it with a mass. I did not fix it for this course, but I think it's something that we can actually treat, right? So for curiosity's sake, I will enjoin you to check what is called Autodesk Insights. Autodesk Insights is a website where you can upload your mass model and do different energy or different analysis, right, on them. So it's very useful. I wish I actually plan to show you how it works, but we'll probably do it another time, right? So another is accurate visualization. Now, what does that mean? Your sketches and some physical models or softwares like SketchUp are really not as detailed, right, when it comes to the distance between this and this. Definitely you can actually be detailed, right, but they are really not for construction documentation that Revit is very strong on, right? So that's one thing, that's reason why is good to do it in Revit. Now another is sites and context modeling. The fact that Revit has already inbuilt solar analysis is very good, right? Another is collaboration and BIM workflow. So you could actually start with your with your um with your mass model, and you want your structural engineer to be able to see how the geometry of the building is going to be, so that they can give you an idea of how the structural system might be. So you have not entered doing your floor plan, right? But like, you already have an understanding of how the geometry of your building, which is a big sculpture, a big physical product, right? How it's going to be, and structural engineer is able to tell you that, oh, if we are doing it like this, so this one that I do it curve, we will have to use dark grid systems, right? Or we might have to have different columns on different grids or something like that. So now one uh I actually forgot what I was going to say now. All right, but one of the things that I can tell you that you enjoy with Revit is that you can be able to do a lot. Okay, I remember what I want to say. So now Revit is actually the main software. CM, there are different softwares you can use for anything, but I can tell you that Revit is the main software. Why do I say that? Almost all the softwares that we use are tying back to Revit now. Now, before, when people want to do this complex models, let's say 2010, 2011, people had to do it in Rhino, import it to Revit, right? Export it from Rhino, import it to Revit, and they're able to do stuff like that as an SAT, yeah, normally SAT, as an SAT file, right? But now, because some people have seen the need for this, I've forgotten the guy that actually created it, but there's now something called Rhino Inside. So Rhino Inside is actually a software that was created by an architect, right? That allows you to do complex things with Rhino and see what you're doing in Revit in real time, right? Or you're able to do complex things with Grasshopper, because Grasshopper is really the main guy, not gonna lie, right? But you're able to do complex things with Grasshopper, and you will see what you're doing in Revit in real time, right? So you don't need the whole I export, I import again, right? So it is looking at Revit and Rhino as a system on its own, right? We'll probably look at that. Only God knows, right? All right. So let's actually now go to the main thing, which is Revit. So I'll be showing. Okay. So if you can see my Revit screen, please can I just see more reactions? If you can see my Revit screen, can put another thumbs up. I will see it. All right, all right, all right. Thank you, thank you, thank you. Okay, so let's jump straight to Revit. So now, one thing that we're able to explain is how, in general, Revit treats masses. So the question now is, how does Revit treat masses? So now, as we said before, for the context of digital models, right, we are dealing with digital shapes, curves, voids, and so forth and so on and so forth, right? And at least as we're going through the course, we'll be able to see how we would able to achieve those. So now, if you have not gotten the course outline, to be able to know what you can expect from this course, right? If you still have the question, you just check our channel. You'll be able to see the link to get it. So when you fill the link, it automatically sends the course outline to your email address. So you'll be able to know what to learn from this. So okay, let me even show you. So this is actually Rhino Inside. This is like Rhino Inside when you install the plugin for Revit. So if I press start like this, my Rhino actually opens, right? So that's just by the way. So let me go back to where most of us land when we enter Revit. So I will make this very beginner friendly as possible, right? So that people can actually understand. Yeah, please. So if you have any question as we are doing this, as I said before, just unmute yourself and interrupt me. Yes, actually interrupt me, right? And if based on the time that we have, um, I'm able to answer your questions, definitely, we are going to do that. All right. So I'll create a new model. I'll go to architectural templates as most of us usually do. And okay, I have this. All right. So now, as I said before, there is the way Revit treats massing is like another thing on its own. So it does not treat massing uh, as part of it. In contrast to Rhino, where there is no difference between a conceptual mass and the actual building, or SketchUp, where there is no difference between the blocks that determine your spaces or the blocks that determine the floors of a tower and the actual building that has walls and everything is. So Revit just does that well. So now there are two different ways of achieving massing in Revit. I said what? There are two different ways. Number one is called in place mass, which is massing in a project, in a Revit project. Another is actually what Revit calls conceptual mass. They are honestly the same thing. One is just inside your project, one is a different project entirely, right? So now, to be able to see the one in your project, you will go to, in your tabs, you see architecture, structure, steel, blah, blah, blah. You will see what is called massing and sites. When you go to massing and sites, you would see a part called conceptual mass, you see model by face, and you see model sites. What we need to look at is conceptual mass. Now, what these 4 or 3 buttons are for is that, number one, this one is for you to be able to control the visibility of your mass. What I say, the visibility of your mass. So if I want to hide my mass, this is actually what I need to do. So you see here, you see there's show mass by view settings, there's show mass floors, form and floors, there is show mass surface types, and there's show mass zones and shades. Honestly, Revit is deeper than the surface level, right? So we really need to explore them. All right. So the one next to it is called the in place mass itself, and the one next to it is place mass. Now, this place mass, when we select it, it tells me that, oh, no mass family is loaded. Now, the way this works is that it works like a component, So when I've done that other mass in another project, right, and I want to actually bring it here, I'll just come to place, I'll have imported it here, and I'll just put place mass. So let's say I have a mass that is just a cube, and I need to scatter the cube around to depict different buildings in a particular zone, right? You could just this be picking, just putting them where they're meant to be. Okay, so now when I select this in place mass, because that's where we start creating our mass inside a project, inside our architectural project. So you could have been working on your project already, right? And you want to know how, let's say, the height of your building is affecting something else, or let me say, you want to see how the geometry of your building can be or should be, right? And you know that, oh, your straight walls are not what you want, right? Or you want something slanted, and Revit is the normal Revit is not allowing you to slant it, right? A way to now do it is now actually do it inside your project. Now, the main advantages this has over the other one is that you're able to have those parameters, like if your mass is parametric, which again I will explain, we'll actually do a good parametric mass. If your mass is parametric, we'll be able to tweak it inside this project, right, in any way, rather than something that we're bringing that is just, so that one you can also be able to tweak it, but you don't have that much freedom as you can when you have it in your project, right? So the other one is now, I would say that the good use of having a different mass project, right? So we're going to touch that one. Just listen to me, then by as we're doing this, you just understand more. So the advantage of having that other mass conceptual mass family or project is that you're able to use that particular thing in different projects. So there was even a time that I did a walkway. So the concept I was looking at for this walkway is that, oh, I want to have a walkway that is not that that the structural system that is at the front is different from structural system that's at the back, but they are the same family, right? So see, I'm using grammar. All right, but like, okay, uh, what I'm just trying to say is that having it in a different project is helpful for you to be able to do more stuff, right, in other projects. So now, when I press in place mass, it asks me that, oh, what is the name of the mass I should call it, right? And let's say building concept 1. Okay, so let's call this one building concept 1. So you can actually have different masses, but yeah, let's just do this one for example. All right, so when you enter this massing space, there is something that you would see and you would notice is that for both this massing environment and the one that's conceptual, that's outside your project, that can be outside the project, two of them have the same environment, and the environment is different from normal Revit environment. So normally you are meant to see architecture, structure,
Sorry.
I think what was it? I'm gonna forget all this thing now. So all those things lined up like this now. But now we are not seeing them here, right? We are seeing create, insert, view, manage, add-ins, then my like the different other plugins I have, then modify, right? So normally when you open yours, you will not have all this Lumion, Revit, and Rhino inside. Normally, you will normally just have create, insert, view, manage, add-ins, then modify. Those are the basic things you will need for your massing environment, which is actually one thing that is good because it helps you to streamline the amount of complexity that the environment can actually pose on you. Because one thing we should be very truthful about, there's a way you start using a software, and the software is just intimidating, right? That's where something like Rhino now, right, in the sense that it's very intimidating when you just look at it, right? But it's very good in the sense that Revit has been able to streamline this and not make it complex for us. Okay, so now let's now start looking at the tools that we have here inside this environment. So what we have is create. You see create, in create, you see properties, which are number one, your properties of any form or your view, then family types and family category and parameters. So this is really where we'll start playing with things that deals with parameters, or as we usually say, parametric. Right? So this is really where we'll start. So here you can actually start giving your mass some particular formulas that if you tell it that, okay, because the way my building is, as it's increasing, I want the base to be increasing by half, right? Or I want it to be increasing by 0.65, or I want my base to be increasing by um 0.5, or I want to be increasing by 0.2, right? That's where our parameters will start putting on shape. So now beside that guy, you see this section called draw. You see model, reference, and plane. Now these are really the main things that you would use, honestly, when it comes to massing, in the sense that you will need your model lines, because that's what you use to make your form and your geometries. You will need your reference lines, which also can make forms and geometries, but they are good for giving direction to any form. So as at least next class, that's when we'll start experimenting with the use of these two, right? So we'll be able to mass some couple of things. Let's say we'll mass a cup. Probably your building looks like cup. Only God knows if how building will look like cup. I'm just saying, sure. But we'll actually try to actually mass things, right? So mass different things, and so that it will be very flexible and know, oh, this is okay, that's, oh, this is how you would do this when you need to do this, or something of that sort, right? So yes, we have model, reference, and plane. Now when I select a model, you would see the normal draw tools that you have in Revit. Apart from one guy, his name is Spline Through Points, and actually points. So you see this guy called Spline Through Point. No, we will actually use it. So yes, so you see line, rectangle, inscribed polygon, and circumscribed polygon, TD things, circle, your different ways of doing curves, spline, then spline, which actually called Spline Through Point, but you're able to call, it's Rhino that calls this spline through points. So this one is called start end radius arc. Sorry, it's spline through points now. Sorry. So you actually see spline through points here. So then ellipse, partial ellipse, then peak line. The normal things we actually know, right? And I can just draw, if I select this line, I can draw a line, different lines, blah blah blah. My lines are anyhow, right? So yeah, me just drawing things, no, just anything, right? So if you are really following, I'll just enjoy that. Just try to draw anything. We are not trying to be perfect, yeah, right? So yes, after that, another thing you will see, your rectangle, your spline. So the spline, I'm talking about this one, the spline. So spline uses what is called a NURBS curve. Forgotten. So NURBS is actually like NURBS. It's a mathematical way of calculating a curve, in the sense that based on let's say in a very good way to understand it, based on the way it is being stretched. So you can see that this one, as I stretch this particular thing here, when I select it, you would see this thing. As I stretch it, you'll be able to see it, right? And other things, let's say you're trying to fillet a place, just basic things that we usually do with our detail line or model line in Revit. So the same with our reference. When I select reference line, you would see it. You would see line, the same thing. You would see normal rectangle. You would see again spline. So it's just the same thing. But one thing that you will notice is that when you create a reference line, a reference shape, a reference anything, you would see this thing here. You will see is the way it shows it. You will see you would see something like you would see as if it's trying to show you that, oh, there is a space here. So I will explain what it does. Let me explain it now. So let's go to our 3D view. Our 3D view is at the top. So when I click my 3D view and I show you this particular line, a way of differentiating them is that most times your model line is black, your reference line is green. Based on your settings, you can change it to whatever that you want, right? But based on this settings, you can see that this is green. When I select it, you will now start seeing that it's giving me like line at the end, line through. I'm like, what's this? Now, what it's actually trying to depict is that a reference line is primarily a path through something, right? And it has different axes. You can see that, oh, this one like this, right? This one that is vertical, this one that is vertical, yeah. So this one that is vertical is one plane, this one that is horizontal is one plane, this one that is at the end is one plane. No, this one that is even at this end is another plane. So it's able to tell you that, okay, in a reference line you can actually have different planes. And those that at least work with Revit, right, you will know that Revit works primarily with something called work planes, which will now take us to what is called reference plane. Now, look at a reference plane as the canvas at which I am drawing. Now, you see that if you are drawing on a canvas, you can't be drawing on the front of the canvas, right? And you will see what you are drawing on another plane. So is when we start doing these examples that we're able to see, okay, how reference plane really works. So as I said, reference planes are just look at them as the canvas at which you can draw something, right? So reference planes, right, are primarily just one line. They are usually line, and you will see them with this broken line. Again, they are normally green, right? They are normally green. So you will see on this one, you will have on the side, you will see what is called click to name. So you can actually name this particular reference plane. Now, let me now try to go to something else that we are trying to explain, which is what is called work plane. So I'll just select all these things, Windows select, drag, click, and I'll delete this, right? Why are you not deleting it? All right. So because I want to show you one of the major things that you will need to learn when it comes to massing is work planes. Actually, how to understand how work planes work. Work planes work. How work planes actually work, and how they are actually used, right? So now, as I said before, look at work planes as the canvas at which they are drawing. Sorry. Okay, I was just hearing some noises. All right. So I said the canvas at which you are working. Now, what this reference plane now does is that it allows you to draw that canvas yourself. Now, it's not as if you draw the canvas like a rectangle. What it does is that it treats it as an infinite plane, not like, as you say, the canvas, like let's say an infinite canvas, right? Like you need to draw something. Now, let me now do this. Let me draw. What I'm doing, I'm going to plane, I'm going to draw, and I'm going to click once, drag down, click again. I'm creating one reference plane. Click once, drag down, click again. I'm creating another reference plane. Click one, drag. I'm creating the third reference plane. Now, just follow me. So don't worry, you understand where I'm going through when we do this. Okay. So when we click on this, let me name this one 01. Let me name this one 02. So what I'm doing to name it is that I select it. You will see this at the edge. You will see this click to name. Just click on that. You will see this, and I'll just press 03. Right. So me now having this, right? Let's now go to our 3D plane. Now you can see that, oh, I cannot actually see that thing, those lines that I drew, because they are actually not lines, they are planes. Now, the way it works is that the canvas at which you're working, you will not be able to use that canvas on that particular view that you drew the reference plane. I'm calling it canvas, but it's actually called plane. But canvas is just something that you need to understand more. So you will see that when I select this one, it's actually a straight line like this, right? But now, for me to be able to use this plane, I need to use it on a view that allows me to see it on a perpendicular side. So you can see that this is here. That means that if I'm looking at something in this direction, or in this direction, right? I'm just drawing arrows for you. That is where I can be able to tweak all this that I actually drew. So now let's go to 3D view. Now 3D view is able to help you. Now you can see what I did. Now I can be able to see the directions at which those lines are going to be. Now the question is now that, oh, how can I now see those lines, right? Or those planes? As I said, that they are actually canvases, as we said. So I go show, and what it's showing me is a work plane. Now, one thing you should note that there are two major work planes that you have in Revit, which is number one, your level, and number two, your grid lines. Are you hearing me? So your levels and your grid lines are automatic work planes, in the sense that you can actually draw on them. So even that's just the way Revit works. For you to draw a wall, even in your 3D space in Revit, you have to draw it in respect to a level. So that level is like the work plane at which we are drawing the thing, right? So the same as this. Now I want to see those levels, or sorry, the work planes that we created. These lines. As I said, the way of learning is that number one is broken line. Number two, you see 3D here. That's one of the ways of actually identifying that, oh, something is a reference line, right? So now I now need to see my own, the one that we just created. So I'll go to this side. You see this actually called work plane. When I go to set work plane, clicks on set work plane, I will now go to see this placement plane here. I'll go here, and now you will see the reference planes, or the placement planes that we, or the, as we said, as we called it, canvases that we can really draw, which is level 0, level 1, which are the levels we have. If we had grids, it would be parts. Then we have reference plane 1, reference plane 2 and reference plane 3. Now you see that this one that is called reference plane 1 is because this one like this that we did, this one, see, is what we actually called reference plane 1. You see 0, 1. See the 0, 1 here. So like the reference plane 1 is actually 0, 1 here. So now, when I now go to set work plane and I choose reference plane 1, you will see, that's changed from level to this one. Now you can see that this reference plane 1 that I have here is the same as this that I'm seeing here. So as I said, it feels like a canvas, but it's like an infinite canvas. Now, if I want to draw anything in Revit, as I was saying before, it has to be in respect to a work plane. Now, see where massing does you different from the way you do on normal Revit, where you work on normal Revit, right? Now, I can actually draw a line. So you see, I already did show and I chose model line, though we're actually going to go more in depth into this, but when I select this, I can actually draw on this plane and come here now and even draw another thing on this plane. And I will see these two in the same view, right? And that was one of those flexible things that you would notice about. One of the flexible things that you will notice about Revit, right? One of those flexible that you notice about massing in Revit. Now, let's now do the same. So I want to see this one I called 02. So I'll go to again, set work plane, which is this, set work plane. I will select reference plane 2, and you will see that it's not much showing this. So now what this means is that any line I draw now, no matter how the line look like, the line is curved, the line is straight, it will be on this particular work plane. See, so even if I'm drawing it outside this blue thing that is definitely this blue thing, you will still see that it's on this work plane. Now you see that, see, like it's like a line in 3D space, right? It's like a line in 3D space. So this is one of those very, very useful things about using massing or doing massing, is that you can be very, very flexible with whatever you're trying to do. And that is one of the good things about actually doing massing, right? So the same thing, I actually want this one, which I labeled number 3. Let's do that again. Set work plane, in placement plane, I go to reference plane 3, and when I do that, bam, it jumps. Now, mind you, you can be selecting all these things that it will not show you like this, so right now, how am I seeing mine like this? You will see in my work plane there's this thing called show. So what it is called is actually show work plane. So if I deselect it, I'm not seeing that blue rectangle again. Now that doesn't mean that anything I draw will not be on that work plane. It's just that I'm not seeing the work plane. But most times it's better you actually turn it on, because it's good and it makes you not to mix things up. So when I select this, you can see there is this guide. So then I draw again. Let's draw something different. Let's say our spline 3 points. Yeah, so these are our spline 3 points. So you can see this one too is okay. There's one thing. Okay, so I will still go to that. Let's use spline. Let's use spline, normal spline, because spline 3 points is very 3D like. But we'll go to that later. Though. So based on this, we'll just draw our different spline. So I said that it does not. It's an infinite canvas. So you can see that the line I drew. Yeah, you can see this line that I drew now. If I select it like this, you see that it's on that particular line. This one is on its own particular line. This one is on its own particular line. Like I said, that these are 3 different canvases that we have drawn something on. this is one of the basic things that you now need to know about massing, so that when we now start doing more things, you now understand, or the understanding you have of work planes are now better, right? They are now better. So yes, these are the major things that you need to learn when it comes to massing. And I can tell you that if you can be able to understand, especially when it comes to work planes and actually model lines and reference lines, you'll be able to do any shape exactly. So now, what we'll be looking at for our next class, because the class of today, we have expanded what we're meant to learn. Okay, it means one more, which is how to organize your massing workspace efficiently. Now, there is no there is no how do I put it? There is no shenanigans in trying to organize it. But what I would tell you is that now I selected finish mass. What I would tell you is that for everything you want to do, right, treat one mass different from another mass. You can have one mass for the concept of your building and one mass for your actual building. So try not to have different masses on one particular mass family. So what I'm trying to say is that, let's say this is how my building concept is, but the way my building is now not as jaga jaga as this, right? What I will do is to go to in place mass again. I'll create another mass, right? I'll say this also, this is my main building, right? And I have a very clean slate. Nothing is disrupting me that I've done before, right? So try to actually do that. A way you can a way that this can work is you actually noting the particular different masses that you would actually need, right? So yes, based on what we're actually meant to treat for this class, these are all. So let me show you, just for those that don't have the course outline yet, what we are going to learn for tomorrow's. Oh, you see tomorrow? That's next week Sunday, 7 p.m. The class we're going to have by next week Sunday. So the first thing we're learning is actually doing things in parameters, right? What parameters are, what constraints are. We'll be doing surfaces. We'll be doing different geometries, right? Like just different geometries, right? But we would actually start with that because that's more interesting than actually parameters, right? So we'll start with different geometries, extruding things. We'll look at as I said again, we'll try to make it very understanding by doing real life examples of buildings, right? And adaptive component. So we're going to touch on adaptive components, although we're not going to do it like, what's the name? I'm not going to do it outrightly, right? So for this number two, next class will be most likely will be longer than this. I really don't know, but it's either that we actually cut what we're going to do next class, or we'll try to do everything right and extend the period we have. Now, please, we have actually come to the end of this class, and thank you guys for staying till this period in time, right? Really appreciate showing your support, and I hope you really actually learned something. So now we have a big news. We have launched our WhatsApp group chat. So now this one is a group chat. You can send messages ask questions, inquire on anything, we have we are going to have a particular chat for architectural jobs and gigs that actually come our way. So those that have can talk to the admins. The admins, we put it on the group chat so that those that are interested would be able to hop on them. So I personally have people asking me, especially graduates, asking me that they need graduate architects, right? So I would put them there. Um, so yes. So for the recordings of this class, let me even stop recording. So for the recordings of this class, they are available for those that are members, right? They are available for those that are members. And to join is just 2.5 per month. If you are paying like for 2 months, is lesser. We're paying for 1 year is lesser. So we already have two people that we have given for free, giving those membership for free, which will be 2 months free. That is Chioma and David. Chioma, I've not seen your message. Oh. If you want us to give it to another person, no problem, right? But I've seen from David, I'm not seeing from Chioma. Now, for today's class, I already said that we actually have 3 more free access to give out. Now, for 3 people that are going to share what they have learned in today's class, just in 2 minutes, right? Uh, just share what you learned in today's class, and yeah. So if you want to share with us, just
Hi, Glory. Can you hear me?
all right. I can hear you. I can hear you, David. Okay, Abiola, are you speaking?
Okay, good evening. Good
All
evening,
right.
Glory.
All right. Good evening.
Yeah, thanks for sharing with us from your wealth of knowledge. It was really impactful. Session was really impactful. Okay, so I just want to pinpoint things I learned. So I learned that maxing is actually a perception of the general shape of a building, and also the complexity of softwares like the Revit and Rhino we use is based on complexity of our projects. Like how complex the software gets is determined by complexity of what we are doing as like the projects. So we should bear in mind that software is not actually complex, right? That's like two of my takeouts from the session. Thank you.
All right. Thank you so much, Olawale. So just again, send me a text message. Send me a message, um, and I would give you access to the member group chat. So main two people, anybody. Once it's 8:25, we'll just call it a day. Anybody else?
Hello, can you hear me?
Okay, I can hear you, bro.
Glory, can you hear me?
I can hear you. I can hear you.
Okay, so one of the things I learned is that massing is a perception. That's the first thing I learned, and then I learned that one of the most important things when we are, massing is that we should separate our masses separate our masses, particularly when we have like concepts. When you shared the sketches and everything, I just learned that it's important to separate all of this. If not, our work Hello?
All right, David. Yeah.
Yeah.
Okay. Thank you so much. Thank you so much. So one more person. One more
Hello, good evening.
person.
Hello, can
One
you
more
hear me?
person. Though we actually have members here. We have some of our members here.
Hello,
Adini
good evening.
Femi. So anybody, any other person trying to speak?
Yes, good evening. Please, can we hear me?
Okay, yes, I can hear you.
Okay, yeah, good evening, sir. Thank you for sharing with us what you know. Okay, so basically what I learned from the class is how massing is not just about building complex design, but it is to actually aim at something, like just like you shared us some slides, how it works with circulation, how we can use massing to also see how other buildings around our building works, just like I said circulation, um, designing to adapt with climate, how let's say a tall building can affect, let's say, shorter buildings around our buildings. Like, so massing is not just building complex designs like that. So that was what I learned from the class, sir. Thank you. Jesus.
Thank you so much. Thank you so much. So again, please send me a message so that I can also add you. But yeah, thank you guys for joining the class. I hope, I honestly hope it's helpful, honestly, because that's just the main aim of this. All right. So see you guys in next class. If you want to join the community again, it is you do not want to talk. If you like, I don't want to talk. Oh, no problem. You can actually join. I would forward the information that you actually need, right, to register. So if you make the payment, just send a message to me or the admin, and you would be able to get access to the community. So yes, the recording for today's class will be available there. And yep, uh, thank you guys once again for joining today's class, and see you next week, same time. Um, I'm going to learn a lot. All right, so goodbye, everyone. Have a good night.